Hello students, today we are going to see one very important concept of number system, that is finding the unit digit. Finding the unit digit. How they will ask you questions, I will tell you now. First I will tell you how to find the unit digit normally. Like if I tell you that what is a unit digit of 2 into 2, you will say it is 4. If I tell you what is a unit digit of 3 into 6, you can say the answer of 3 into 6, the product of 3 into 6 is 18, but the unit digit of 18 is 8. If I tell you what is the unit digit of 2 into 236, you can tell that the total answer will be 472, but the unit digit will be 2 only. Okay, so one thing we can see, if I tell you, if I give you a normal expression, that is 22 into 36 into 48 into 78 into 24, and if I tell you to find the unit digit, now it is extremely very difficult to multiply each and every number and then finding unit digit. It will be really difficult. So for finding unit digit of any expression like this, you have to forget all the other numbers except the unit digit. Means you have to remember only the unit digit of all these numbers. If I tell you, you have to remember only this number and this and this and this and this one. So if you multiply only these numbers, 2 into 6 into 8 into 8 into 4, you will be getting the unit digit same as unit digit you will be getting in this product. Means I would say unit digit in first one and second one, both will be same. And when I'm saying only unit digit will be same, not the product. Okay, because this product will be less and this will be high. Okay, so unit digit, how will you find? I would say now you have to group it. How you will be grouping it? Check. If I tell you how will you group it, check. I will tell that 2 into 6 is 12. Again you have to forget the one, you have to remember only 2. Then 2 into 8, 16. Forget 1, only remember 6. 6 into 8, 48. Remember only 8. 8 into 4, 32. What is the, you forget 3. What is the unit digit? 2. You will be getting as 2 only. This is the process. If you want to do it little faster, then how you can do it? You can do it in this way. I would say 2 6 are 12, 2. 2 8 are 16, 6. 6 8 are 48, 8. 8 4 are 32, 2. And then answer will be 2. Okay. The same thing if I do it for addition. If I tell you, same way, if I tell you 2 plus 2, you will say unit digit is 4. 3 plus 6, unit digit will be 9. If I tell you 2 plus 2, 36, what you need to do, you have to take care of only unit digit, means 2 and 6, added 8. Let's check about this. 22 plus 36 plus 48 plus 78 plus 24. What is the unit digit of this one? I already told you that you have to remember only the unit digit. Forget these numbers. These numbers you don't even remember, don't even consider. These numbers are not needed for finding the unit digit. What you do is 2 plus 6, 8. 8 plus 8, 16. So you have to take care of only 6. 6 plus 8, 14. So you have to take care of only 4. 4 plus 4 is 8. So unit digit is 8. By this way you can find the unit digit. But they will never ask you these type of questions in GRE, GMAT or CAT exams. Okay, they will never ask you, they will never give you this expression. This might be useful in finding the answer quickly for option verification, but it will never be asked directly. How they will ask you, I'll let you know. How they will ask you, they will tell you to find the unit digit of something like 487 raised to power 28. Now they will tell you to find the unit digit of this one. Now if you go normal method like 487 into 487 into 487 28 times, now it will become very difficult to solve in this way. Even you cannot even solve it. Why? Because if you go for 28 times, even calculator if you are using also, there are not so many digits in that, so you cannot even find it. So what is the other way? There is one concept called cyclicity. If you use this concept, you can easily find the answer for this one. That is what is the cyclicity concept. I'll just give you a basic, very brief introduction about the cyclicity. So I will tell, suppose there is one series. I'm just writing that series down. That series is something like this. 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 like this. Or I will tell you, because our remainder, it will be matching with the remainder. So what I will tell you, that instead of this one, I will tell another. I'll take another. Suppose this 5 6 7 8 5 6 7 8 5 6 7 8 5 6 7 8 5 6 7 8. This series will continue, I would say, like maybe 500 times or something like this. Okay. So just remember, I'm not considering this series now. I'll just, okay, I'm not considering this one. Now, if I tell you, if I say that this series is only till here, means forget only this series. And if I ask you what is the third term, you can simply tell, okay, 7 is the third term. If I ask you what is the sixth term, you can simply say 6 is the sixth term. Or if I tell you that what is the fifth term, so fifth term is 5. Or if I ask you what is the ninth term here, so 1 2 3 4 5 6 7 8 9, so 5 is the ninth term, means. But if the series becomes very big, if the series becomes very big, something like this, and they are asking, they will not ask you something like fifth term, sixth term, or 11th term, or 12th term. They will be asking something around something. They will ask like, tell me the 12th term or 787th term. Then how will you find? Obviously, you're not going to write this whole series and then going to count and then find. No, it's not at all possible. It is not humanly possible. And if it is humanly possible also, it is not possible to do it in the exam hall. If you do only this question only, you'll be able to do no other question. So we got to know another thing, that is, we know that from this series that every 4-digit, after every 4-digit, if you look carefully, 5 6 7 8 5 6 7 8 5 6 7 8 5 6 7 8 5 6 7 8, after every 4-digit, the digits are getting repeated, right? After every 4-digit, the digits are getting repeated. If I tell you that somehow, if you maintain this thing, if I tell you that what is the 11th term, what is the 11th term, so what I'm going to do is, I know the 4 is the cyclicity. After every 4 times it is getting repeated. So what I'll be doing is, I'm just going to find the remainder of when 11 is divided by 4, means the term you are going to find, that is 11th number divided by the cyclicity. What is the remainder? I would say the remainder will be 3. And I will tell you that 4-digit here, 4-digit here, then this digit will be 9th one, this will be 10th one, this will be 11th, and this will be 12th one. And if you look carefully, if I talk about 9th term, you divide by 9 by 4, you'll be getting remainder 1. If you divide 10 by 4, you'll be getting remainder 2. If you divide 11 by 4, you'll be getting remainder 3. If you divide 12 by 4, you'll be getting remainder 0. 0, and I would say or 4. Why I'm saying or 4? If I tell you there is one number called 16 and you're going to divide by 4. So one way is that you can say 4 4s are 16, so remainder is 0. Another way is also there, that you can say that 16, 4 3s are 12, and the remainder is 4. So one multiple less you are going, so I can say 0 or 4 is the remainder here. Okay. Now 11th term you have to find. I'm telling you that you have to find the remainder of 11 by 4, and this remainder comes 3. And 3 is associated with which number? I can say on 11th by 4, remainder 3 was there. What is this number associated with? With 7 it is associated. So I can say the 11th will be 7 number. Okay. If I tell you that find the 787th number, so I would say, again do one thing, 787 divide by 4. Then what is the remainder here? How about will be the remainder here? I would say the remainder here will be 4 2s are 8 and 4 1s are. So remainder here also it will be 3 remainder. Okay. So remainder 3 means number will be 7 if you look carefully there. But suppose number is something like 1 1 12. Then 1 12. Then what will be doing? 1 1 2 divided by 4. Find the remainder of this thing. I would say remainder of this will be 4 3s are. I can say remainder will be actually 0. Remainder will be 0. but we will not take 0, we will be taking the remainder as 4. Why will take remainder as 4? We'll discuss this thing in the subsequent lectures, or maybe in further time we'll discuss this thing. Okay, we'll not take remainder as 0, we'll be taking remainder as 4, because you know that 4 is also acceptable remainder and 0 is also acceptable remainder. Okay, now we are now, see this, if this series is given we can find like this, but if series is not given, then how will we find? So for that also I'll tell you how you can find the answer. Suppose number is given something like this, that you have to find the 2 raised to power 73. You have to find the unit digit of this number. Unit digit of this number you have to find. So one thing is there, that it will be something like 2 into 2 into 2 into 2. How much times? 73 times. Now in previous question we know this series. Okay, we know this series, that this is the series, but it is not in multiplication. But here if you see, we are seeing in multiplication. So this is not a series actually, you know, in multiplication it is a multiplication, it's a product. Okay, so how we are going to find? Now if somehow I find the cyclicity of 2, and then if I get the cyclicity, then the remainder thing I can apply and then get the answer. So let's check the cyclicity of 2. I can say if it is 2 raised to power 1, because here it will be 2 raised to power 1. If I take this thing alone, 2 raised to power 1 it will be. So I can say the unit digit will be 2. If I take 2 raised to power 2, means I take only these two terms, so it will be 2 raised to power 2. The unit digit will be 4. If I take 2 raised to power cube, it will 2 cube, it is 8 unit digit. If I take 2 raised to power 4, it is actually 16. Number is 16, but unit digit means 6. 2 raised to power 5, again it will be 2. 2 raised to power 6, it is going to be 4. 2 raised to power 7, 2 raised to power 7, 2 raised to power 7, just a minute, 2 raised to power 7, it is going to be 8, and 2 raised to power 8, it is going to be 6. Now you might ask me, sir, suppose if I don't remember what is this 2 raised to power 8, what is the 2 raised to power 8 value? Actual value, this 2 raised to power 8 value is 256. Suppose you don't know this 256 value, then how will you get that? I already told you. Suppose you are going to find for 2 raised to power 5. 2 raised to power 5, you have to find a unit digit. It is what? 2 raised to power 4 into 2. 2 raised to power 4 unit digit is 6. 6 into 2 is how much? 12, and unit digit is 2. Same way, 2 raised to power 7, suppose 2 raised to power 7, you don't know. So 2 raised to power 4, 2 is square. You can say 2 is, this is 6, this is 4. What is the unit digit? 4. So you can simply say that it is 4. Okay. Or wait. 6 4s are 4. 2 7s are 2 4 8 6. Okay. It is only, see, it is only 2 raised to power 6. One more 2 you need. 4 2 6 and 1 7. So it is into 2. So into 2, that is 8. Okay. So 2 raised to power 7, that you can get as 8. So like that you can find the cyclist. You can see some unit digits you are getting. Okay. Now let's see something here. If I tell you to observe something here, observe carefully that after every 4 digits, the digits are getting repeated. 2 4 8 6, 2 4 8 was there, 2 4 8 6. Can I say cyclicity of 2 is actually 4? Yes or no? Cyclicity of 2 is actually 4. Now I have to find the value for 2 raised to power 73. What I would say that the 2 raised to power 73 unit digit will be same as 2 raised to power remainder unit digit, where remainder is the number n is divided by the cyclicity. Whatever remainder you are going to get, if you divide it and get the remainder, then you can say the unit digit of the 2 raised to power remainder will be same. How I can verify this thing? For that I already explained you this concept. This is the remainder concept. We have just given this 9 by 4 for the first one, 10 by 4 for this one, 11 by 4. It is not only for 4, for any number of digits it is possible, but 4, why I told you for 4? Because for our numbers 2 3 7 8, 4 is the cyclicity. Okay, and this is what the most difficult for many of the students. Okay, so if I tell you that you have to find the cyclicity of 2 raised to power cyclicity of 2, that is already 4, how you are going to solve? I can say 2 raised to power 73 will be having the same unit digit as 2 raised to power remainder, where remainder is n by cyclicity. What is the n value? 73. What is cyclicity value? 4. So what you can say, what is the last digit you are going to get? I would say the remainder you are going to get is 2 1 1, right? So I would say 2 raised to power 73 unit digit will be same as 2 raised to power 1. 2 raised to power 73 unit digit will be same as 2 raised to power 1, and 2 raised to power 1 already we know, that is 2. So unit digit of 2 raised to power 273 will be 2. Okay. Same way, if I tell you that you have to find the unit digit of, I would say you have to find a unit digit of 122 raised to power 486. You have to find a unit digit of this one. So how would how you are going to find? I would say it will be same as, now I told you before itself that if it is 122 raised to power 486, so it is actually 122 into 122 into 122, how many times? 486 times. But I told you if you have to find a unit digit, means you can neglect all the details, all the digits other than the unit digit. So I can say it is 2 into 2 into 2 into 2 and so on, right? How much times? 2 raised to power 486. So I can say, I can consider this thing as a 2 raised to power 486. I can neglect these. Okay, so 2 raised to power 486, you have to find a unit digit. So I can say it will be same as 2 raised to power remainder, where remainder is when the number is divided by cyclicity, right? So number is to 486 and cyclicity is 4. So I can say the remainder is how much? 2. If remainder is 2, means it will be having the same unit digit as 2 square, that is 4. So unit digit will be 4. That will be the answer. Okay, so like that questions they will be asking in GRE and GMAT kind of exams. Okay, now this is only for the numbers which are ending with 2, but we have how many numbers? See, if I tell you how many numbers we have: 0 1 2 3 4 5 6 7 8 and 9. We have these 10 numbers, and our numbers can end with any numbers, right? If I tell you that you have to find the answer for 1 2 3 4 raised to power 5 6 7 8, right? So for that, this is ending with 4, and 4 cyclicity you don't know. So I have dealt with only 2 till now. Okay, so what you can do is, you can remember that this cyclicity, this is your homework. You can take it as a homework, like how I did for 2, finding this thing. 2 is 2 raised to power 1, 2 raised to power 3, 4, something like that. You find for 7, 3 and 8 also. Okay, that 7 raised to power 1, 7 raised to power 2, 7 raised to power 3, and find the unit digit and check whether you are getting the cyclicity of 2 3 7 8 is 4. Okay, that is your homework. Try it. Okay, so I'm telling you the cyclicity of 2 3 7 8 is 4. So whatever procedure you have followed for 2, the same procedure will be there for 7 3 8 also. Okay, the same procedure will be there for 7 3 8 also. Okay, let's see the example. If I tell you example 5 6 7 raised to power 23, you have to tell me what is the unit digit. I can say this unit digit will be same as 7 raised to power 23, and you know 7 raised to power 23 is the same, will be same as 7 raised to power remainder, where remainder value is when this number 23 is divided by the cyclicity of 7, that is 4. So what is the remainder here? I can say remainder is 3, means it will have the same unit digit as 7 raised to power 3. What is 7 raised to power 3 unit digit? I can say 7 square into 7. 7 square is 49, means 9. 9 to 7, that is 3. So unit digit will be 3. So like that, if I give you another example, suppose 128 raised to power 56, right? Okay. Suppose 128 raised to power 46 you have to find. So again, you can say it will be same as 8 raised to power 56. 8 raised to power 56 means 8 raised to power remainder, where remainder value is when this 56 is divided by the cyclicity of 8, that is 4. Okay, so it will be how much? I can say remainder will be again 2. So that it will be same as 8 square. 8 square unit digit is 4. If I give you another example, suppose 28 raised to power 28, you have to find the unit digit of this one. Again, I can say it will be same as 8 raised to power 28. right? And 8 raised to power 28 means 8 raised to power remainder, where remainder value when this 28 is divided by the cyclicity of 8, that is 4. So what is the remainder here? 0. But I told you it can be 0 or 4. So 0 will not take, will take 4. I told you why we are not taking 0. Because if you look for 2, 3, 7, 8, if you look for 2, 3, 7, 8, and if somehow you take the remainder 0, so it will be 2 raised to power 0, 3 raised to power 0, 7 raised to power 0, and 8 raised to power 0. And anything power 0 is 1. So answer will be similar and it will give wrong answers. That is why we are going for remainder 4, not 0. Okay. So we will be taking 4 remainder. So I can say its unit digit will be same as 8 raised to power 4. So 8 raised to power, what is the unit digit? I can say 8 square, 8 square. 8 square is 64 means 4, and this is also 4. So this is unit digit will be 6. I hope you will be able to get the idea. Okay. This is about the numbers which are ending with 2, 3, 7, 8. Now we have another type of numbers. Those are numbers 0, 1, 5, 6. Okay, so any number which is ending with 0, 1, there might be some number, okay, 1 or 5 or 6. Power of these numbers will always end in 0, 1, 5, 6 respectively. Means if I tell you that, tell me the unit digit of 111 raised to power 234, I would say it will be 1 only, because 1 raised to power 230, 1 raised to power anything is 1. Or same thing if I tell 1100 raised to power 5, 6, 7, 8, what is the unit digit? 0. If I tell you 36 raised to power 72, what is the unit digit? I know 6, it is ending with 6, so any power will be ending with 6. And same with 5. Okay, so 0, 1, 5, 6 raised to power anything will be always ending with the same number, that is 0, 1, 5, 6. Now another number, and I can say because it is ending with same, so if you tell in terms of cyclicity, I can say its cyclicity is 1, but cyclicity concept will not be used extensively here, so I can say this is better approach. Okay, now another thing I can tell you that if you are, now we have covered what 0, 1, 5, 6, 2, 3, 7, 8. So two numbers are remaining now. What are those two numbers? I can say those two numbers are 4 and 9. Okay, 4 and 9. So number ending with 4 and 9. So there are two approaches mainly. One approach is cyclicity approach, which I feel that it is not good to find the answer, and second approach is finding the even odd approach. Okay, so cyclicity approach you can say apply the same way, like I will take one question and then we'll solve by both the ways. Okay, so before that you should know what is even odd. So I'm just writing it here. 4 raised to power odd is always 4, and 4 raised to power even is 6. 9 raised to power odd is unit digit is 9, and 9 raised to power even unit digit is always 1. Okay, if I tell you that you have to find the answer for 234 raised to power 5, 6, 7, 8, what is the unit digit of this number? So I can tell you that if you go for this, if you go with the cyclicity approach, if I take this question in the cyclicity approach, 234, 5, 6, 7, 8. So it should be same as 4 raised to power 5, 6, 7, 8, where it should be same as 4 raised to power remainder, where remainder is when the number, that is 5, 6, 7, 8 is divided by the cyclicity of 4. What is the cyclicity of 4? That is 2. Right? If you want to check what is the cyclicity of 4 and 9, the 4 and 9 cyclicity is 2 only. If you want to check, what you can do is you can check like this: 4 raised to power 1, what is that? 4. 4 raised to power 2, that is 6. 4 raised to power 3, that is 4. 4 raised to power 4, that is again 6. So it will be 4, 6, 4, 6, like that will be going. So cyclicity, I can say this is 2 only. If you want to go by cyclicity, so again you can say you have to find the remainder there. So what is the remainder here? Here remainder will be 0, but I told you that you don't have to take the remainder 0, you have to take 0 or don't take 4, 0 or cyclicity. Cyclicity of this one is 2, so 0 or 2. So I can say this is 0 or 2 means it is 4, 2, that is 6. So 6 is the answer, 6 is the unit digit. But if you think that it is a little lengthy approach, so you can simply forget it, because we have easier approach for these kind of questions which are ending with 4 and 9. So I can say that any number is there, so either it will be even or odd. If you look carefully, 5, 6, 7, 8 is actually what? It is even number. So I can say 4 raised to power even. So it should end with 6. Same way if I tell you 5, 6, 7, 8, 9 raised to power 1, 2, 3, 4. So again 9 raised to power even. 9 raised to power even means it will be ending with 1. And if I tell you that 9 raised to power 129 raised to power 129. What is the unit digit? I can say simply that it is 9 raised to power odd. 9 raised to power odd is 1. Okay. Now another doubt you might have, that how to remember that 4 raised to power odd is 4 and 4 raised to power even is 6, 9 raised to power 9, and this one. You can simply remember like 4 raised to power 1 is 4 and 4 square is 16, so 6. Same way here, 9 raised square is 9 raised to power 1 is 9 and 9 square is 81, that is 1. Okay. So like that you can remember. Now based on that, I'm just solving one question in front of you, and then I'll give you some homework questions. With that you can actually practice. Okay. So first question I'm writing is 2 6 raised to power 2 6 into 5 6 7 raised to power 28 1 2 3 4 raised to power 1024 into 38 raised to power 29. What is the unit digit of this expression? What is the unit digit of this expression? Okay, so how you're going to find? Now if this number, suppose this 26 28 1024 and 29 is not there, only this is given 26 5 6 7 1 2 3 4 and 38, and you have to find the unit digit. That is very easy. I told you, you have to consider only unit digit, means 6 7 4 8. 6 into 7 42, that is 2. 2 into 4 8. 8 into 8 64, that is 4. So unit digit will be 4. But that is when the power is not there. But now when power is there, then how you are going to solve? So what I'm going to do is, in this we are going to find the separate unit digit, means unit digit of this one, unit digit of this one, unit digit of this one, and unit digit of this one, and multiply and get the unit digit of the whole expression. Okay, so let's find first for the 26 raised to power 26. 26 raised to power 26. 6 raised to power anything is 6, so unit digit is 6, so I can write 6 here. Okay, now next one is 5 6 7 raised to power 28. Okay, means it will be same as 7 raised to power remainder, sorry, 7 raised to power 28, and it will be same as 7 raised to power remainder, where remainder is when the number 28 is divided by cyclicity of 7, that is 4. So remainder is 0, but we cannot take 0, so we will take the cyclicity itself, that is 4. So it will be same as 7 raised to power 4. 7 raised to power means 4 means 7 square. 7 square means it is 9 into 9 means the unit digit will be 1. So unit digit will be 1. Now 1 2 3 4 raised to power 1024. It is, you don't have to consider this one, so consider only 4. 4 raised to power what? Even. 4 raised to power even means 4 raised to power even means 6, so it will be 6. Okay, now again 38 raised to power 29, it can be written as 38 raised to power, or only 8 raised to power remainder, where remainder is when 29 is divided by cyclicity of 8, that is 4. So remainder of 29 by 4, the remainder will be 1, so it will be same as 8 raised to power 1, that is 8. So that is 8. Now find the unit digit of this one. So 6 into 1 6, 6 into 6 36, 6 into 8 48, so 8 will be your answer. Okay, so that is how you are going to solve. For practice questions, I will tell you that solve these questions. Okay, so first practice question is going to be something like 122 raised to power 122 86. Next question could be 4 6 7 5 raised to power 25. 4 2 9 8 raised to power 20. 1 2 3 4 8 6. Another could be. Now this question I'm giving you, try this question in home, and in the next class we'll see how you can solve this thing. I'm just telling you, it is 1 2 3 4 raised to power 1 2 3 4 raised to power 1 2 3 4. Okay, there's one more thing I want to tell you, that many people make mistake in this understanding, that 2 raised to power, or if I tell you 2 raised to power 4 raised to power 2 and 2 raised to power 4 raised to power 2, these two expressions are not same. Okay, many people they make this mistake. You don't make this mistake, because if you solve it, this is actually 2 raised to power 16, and this one is 2 raised to power 8. A raised to power m raised to power n is what? A raised to power mn. So this is 2 raised to power 8. It is not equal. So don't make this mistake. Okay. So with this, I'm winding up the class. Maybe we'll see in the next class. Okay. We'll see some more concept in the next class. Thank you.